Hi guys, this is my first video trying to help you with your matric maths for the upcoming exams. The idea of this is to just go through the papers, explain what I'm doing. So effectively this is just a walkthrough of, say, the memo, a memo, my memo, and help you guys hopefully to get a understanding of not so much the work, because you should be up to date with the work, but more an understanding of how to go about solving the different problems for your exam. So looking at question 1, now the nice thing with the matric maths papers, in fact with almost all the matric papers, that follow a standard format. So question 1, for example, if we just go to that quickly, question 1 we see it says solve for x, and then we have a standard trinomial. It's slightly more difficult trinomial, but that's not a problem. We have something to do with a square there, we have a number line, we have simultaneous equations, and then we have a roots thing over there. Okay, so the paper as well as the memo and my written notes will be available in the link in the description, so feel free to download it over there. If you have any questions, please just leave some in the comments or contact me directly. Okay, so if we look at question 1.1, so let's just start with question 1 and 1.1.1, a lot of points. Okay, so the first one simply says x squared minus 9x plus 20 equals 0. And if we look at this, there's a couple of ways we can do it. If you want to use your calculator, just remember that this one specifically is quite simple, so we can just use our calculator and we can see, well, we can have an x here, an x here. Just remember the formula, negative b plus minus square root, x equals negative b plus minus square root b squared minus 4ac divided by 2a. So you can either use that formula, or you can just literally plug into calculator, or you can think a bit and you can say, well, what are the multiples of 20? We know the multiples of 20 is 4 and 5. That's quite a simple one. 10 and 2. Now which ones add to get 9? So 4 and 5, clearly 4 plus 5 give us 9, or minus 4 minus 5. So we know we're going to have a 4 and a 5. Doesn't matter which one goes where, but what does matter is which one gets a positive, which one gets a negative. Now because we have a negative over here, obviously one of them must be negative because we have a positive over there. That means that both of them must be negative. So we get negative 4, negative 5. Therefore x equals 4 or x equals 5. Right. We then look at question 1.2 or 1.1.2, and it's the same thing, it's just slightly more difficult. So we have 3x squared plus 5x equals 4. So let me just bring that up just to show you. So we're looking at this one over here, 3x squared plus 5x equals 4, and it says correct to 2 decimal places. Now that one's a little bit different. So what we're going to do is we're going to use okay, so what we're going to do is we're going to just use this formula that I've put down over here. Let me just see the color. So we're going to use this formula over here. Okay, so we're going to use the quadratic formula, or you can use a calculator, but we're going to try and solve it using the quadratic formula. So we first got to get this into a standard form. The standard form is ax squared plus bx plus c equals 0. So let's do that. Let's just note that that is our standard form, and we take that and we simply go, well, that gives us 3x squared plus 5x minus 4 equals 0, right? We take the 4 minus 4 from both sides, or take the 4 across, whichever way you want to think of it. And now we've got our ax squared plus bx plus c. We take that ax squared plus bx plus c and we simply plug it into the quadratic formula which was above. So x equals negative b plus minus the square root b squared minus 4ac divided by 2a. Right, we've got our quadratic formula, and we can substitute in. So x equals negative b, and even if you do use a calculator, just remember you're going to get a mark for this and that. So at least 1 mark for that. So just remember to actually write this in. Otherwise, it's a 4-mark question. You're going to get 1 mark if you're lucky, because you haven't showed any working out. So it's important that you do show working out. So we have negative b. Negative b is 5. So we have negative 5 plus or minus the square root of b squared, which is simply 5 squared, minus 4 times a, which is 3, times c, which is negative 4. All that divided by 2 times a, and a is 3. So we work this out, and we end up with x equals, now you can plug these all into your calculator as you like, or we can work it out in our head, but we end up with this nasty looking thing of negative 5 plus minus the square root, everything inside here works out to 73, and that's divided by 6. Now obviously you're not going to do that in your head, hence why they say 2 decimal places. So x is either equal to negative 2.26 or x is equal to 0.59. Okay, and like I say, it's important that you get this right, because you get a mark for those 2 sections. Okay, it's also good practice to do that. Okay, so we've got our 2 answers. We move on to 1.3. So we look at 1.3 and we see we've got a 2x negative 5 over 3, and that equals 64. So let me just write that down. So 1.3, we have 2x negative 5 over 3 equals 64. Now just as a side note, specifically focusing on that, something in this case x to the power of negative 5 over 3, we can rewrite that and we can say, well, that is the same as saying either 1 over x to the power of 5 over 3, because we have a negative over here. That negative means that it's over 1. And we can look at that and we can say, well, actually that 5 over 3, that divide by 3 part is quite important, because a fraction in the power is simply a square root or a cube root in this case. So we have 1 over the third root of x to the power of 5. And now, while that might not be important to this specific question, it is important sorry, to know in general that this is how we write our powers. So we look at this and we say, well, what do we need to do? Normally you'd get a common base, or you work them out to prime factors and things like that. But in this case, what we effectively have, we have 2 times x negative 5 over 3, however you want to write that, equals 64. And that x is by itself, and that 2 is by itself. So what we do is we simply divide everything by 2. We end up with x to the power of negative 5 over 3 equals 64 divided by 2. 64 divided by 2 is simply 32. Now what we've got to do is we say, okay, well, how do we get rid of this exponent? Well, the simplest thing is we make it everything to the power of 3, right? So we say, well, x to the power of minus 5 over 3. Now I'm going to make it to the power of negative 3 to get rid of that negative. Negative 3 is equal to 32 to the power of negative 3. That negative 3 then cancels with that and that negative. So now you have something which says x to the power of 5 equals 32 to the power of negative 3. And to get rid of that 5, we can take the fifth root. And we do the same on this side. Fifth root. Now remember over here, I said, well, that fifth root can be rewritten, and that can actually be written such as 32 to the power of negative 3 over 5. Now, why is that great? Well, we didn't actually have to do all this work. What we could have done is we could have simply said, if we look at this 5 over 3 here, and the 3 over 5 here, we could say, well, why don't we just flip it and take it across? So we can do that. But it would be nice to show the working, but if you want to just jump to the answer, in this case you can, because you can just flip the fraction there and take it across. And that would be the same with any power. You flip the power, so if it's to the power of 5, it becomes the power of 1 over 5 when you take it across. Okay, and then this is sort of proving that it does flip. So we have, in the end, x equals 32 to the power of negative 3 over 5, and you can write that however you want, but I assume you'd obviously want to simplify it. You could say 32 is equal to 2 to the power of 5, so I mean we could simplify it as 2 to the power of 5 to the power of negative 3, to the power of negative 3 over 5, and then that 5 and that 5 cancel. 2 to the power of 3 is 8, negative, so it's x is equal to 1 over 8. Okay, and you can write that as a fraction or however you want. Okay, right, so let's have a look at the next question. So the next question over here, we have something with a square root on it, and that's equal to x minus 2. So that's fairly simple. Most of the questions in question 1 are going to be fairly simple. I mean, that's the whole point of question 1. It's basic algebra 1.1.4, right? And we have square root of 2 minus x. Square root of 2 minus x is equal to x minus 2. Okay, now what's the first thing we do? Well, it's fairly obvious in this case. We need to get rid of that square root. How do we get rid of that square root? Well, we undo it, and we undo it by squaring both sides. So if we have square root of 2 minus x squared, then whatever we do to the one side, we've got to do to the other side. Obviously that squared cancels with the square root, and we end up with 2 minus x, and that's equal to x minus 2 times x minus 2. And we multiply that out, so I'm going to do this in multiple steps, but you can do it in one step, it doesn't matter. That becomes x squared. So when we multiply those two, when we multiply that one and that one, we end up with negative 2x. That one and that one, we end up with negative 2x again. And that one and that one, we end up with negative 2 times negative 2 is positive 4. Now I'm going to take everything on this right hand side over to the left hand side, or you can take everything just from the left hand side over to the right hand side. Now personally I prefer to keep it positive, not that it makes much of a difference, but I'm going to take everything over here on the left hand side over to the right hand side, simply so that I keep my x squared positive. Just a personal preference, but it makes absolutely no difference in the end. We have x squared minus that one is minus 2, we have minus 4x. Take this one across and we have plus x, plus 4 from that, and then take that 2 across and it's minus 2. Okay, 0 equals x squared minus 4x plus x is minus 3x. 4, 2, or plus 4 minus 2 is plus 2. And that's our new equation. We can solve that. That's a very basic trinomial. Okay, so if we solve that as a trinomial, we end up with x, and the factors of 2 is 1 and 2. It's the only factors. So we have 1 and 2, and minus 1 minus 2 gives us minus 3. Okay, and minus 1 times 2 is obviously 2. So therefore, we solve this and we say, well, x equals 1 or x equals 2. Okay, so we look at question 1.1.5, and we see it says we have x squared plus 7x must be less than 0. Now, this little guy over here tells us that we must have a number line. I hope you can see the yellow. I'll try to use a different color in the future. But that implies that we have to use number line. So whenever you see that, no number line. So we have to solve this. Now, this is a simple trinomial in the sense that we can just take out x as a common factor, and we have x plus 7 left over. So take out x over there. X times x is x squared. X times 7 is 7x. And that's all less than 0. Right. Now, that means if we solve this, and we pretend that instead of being less than 0, let's make it equal to 0, then we have x equals 0, or x equals negative 7, right? Now we know, but it's not equal to, it's less than. So we draw a number line. The numbers that we fit on the line is the ones that we found over here. So we fit negative 7, we fit 0. Then we say, okay, well, if we plug in negative 7, we're going to get 0. If we plug in 0, we're going to get 0. I mean, that's what we just found. If we plug in anything in between there, I don't know, let's choose negative 5 for argument's sake. You can choose any number between 7 and 0, negative 7 and 0. And then I'm going to plug in 10 because I can, and then negative 10, well, because I can. If we plug in 10, start over here on this side. 10 times 10 plus 7, so 10 times 17 is a positive number. It's 170. So we end up with a positive number. And the good thing is, if we have a positive number over here, we're going to get a negative number over here and a positive number over here. But let's just check that. If we have negative 5, we have negative 5 times negative 5 plus 7, which is positive 2. So we have positive 2 in the brackets, negative 5 on the outside, and that gives us negative 10. In other words, we have a negative number over here. And the same thing, we have a negative on the outside times a negative on the inside. Because negative 10 plus 7 is negative 3. We now get a positive number here. And we have to expect that. We should expect that. This is a parabola. So we should expect to see that if the numbers are between there and there, I mean, if we draw this as a graph, we see, okay, we're going to get not quite like that. Because we're on the 0. Let me actually draw that correctly. We're going to get something that looks like that, where this point here is the negative 7 point, that point there is the 0 point. Anything between negative 7 and 0 is a negative, and anything bigger than that or smaller than that is going to be a positive. So we have negative, a positive, and a positive. And that's what this whole thing effectively tells us. Now, how do we write that? Well, we write that by saying x must be. Now, we're either going to choose these outer ones or we're going to choose the inner one. Which one? So we look at this inequality sign and we say the whole thing must be less than 0. So where the whole thing is negative, that's where we put our inequality sign. So x must be less than 0, but it must be greater than negative 7. And that is the answer. Okay, moving on to the next one. The next one says we've got a some equation, and we must solve for x and y. Now we know that when they tell us solve for x and y, it must be simultaneous equations. There's nothing else we can do. And in this case, we've got 2 variables, therefore we need 2 equations. If we had 3 variables, we would need 3 equations. Now, this one's a little bit different to a normal simultaneous equation, in the sense that they haven't given us 2 completely independent equations. So we have to just think a bit. Let me just write this down. We see we get 3x minus y squared plus x minus 5 squared, and that equals 0. So we actually got to think. Now, the first thing you would probably do is say, well, why don't we make these equal to each other, in the sense that we can say 3x minus y squared equals negative x minus 5 squared. And what you would then say is, well, we can square root both sides. add, well, if this little guy here was a negative, then we could, because we would have a positive on this side. And if this is a positive, then we can square root both sides. But because that is a negative, so let me undo that. Because that is a negative over here, we have a problem. So what do? Well, that's quite simple. We don't do this. We avoid that. So let's just cross that out. And we're now going to say, well, what is the other option we can do? Well, if you look at this, what we have is we have something squared. I'm just going to call this guy over here, call that A, and that's squared. Call that guy over there B squared. Obviously we have that equals 0, and we've got this plus in the middle. Now, we cannot have a number, any number, whether it's positive or negative, and square it and get a negative number. This is always going to be a positive number. Same for this one. We're always going to have a positive number. And the only positive numbers that we can plus together, we can add these together because there's a plus here. If there's a minus, different story. Then we use this guy. But there's not. There's a plus. So any two numbers, positive numbers, that you add together, and the same goes for any two negative numbers. So if both of these were negative, the same would apply. The only things you can add together that are both positive or both negative and still get 0 is 0. Right? In other words, 3x minus y must equal 0. When we square it, 0 squared is still 0. And x minus 5, say that's squared, must equal 0. It's the only way this works. So then we can say, well, the square doesn't actually make a difference. We square root 0, we still get 0. We square 0, we still get 0. So now we have something that says 3x minus y equals 0. That's our one equation. Call that equation 1. And x minus 5 equals 0. Call that equation number 2. So this one's fairly simple. We can simply say x equals 5. Yay, done. We substitute that one back into this one, and we can say, well, 3 times 5 minus y must equal 0. And we can see that by taking y to that side, we can see y equals 3 times 5, which is 15. So y equals 15. So we've done y equals 15, x equals 5, and we've solved that problem. Right. Okay, so I want to just go off on a tangent a little bit here and just discuss nature of roots. Okay, so when we talk about nature of roots, or when they say what is the nature of this root, or when will these roots be equal, when will these roots be real, non-real, all that, we've got to take a look at the quadratic equation again. And the reason for that is, well, we have a trinomial ax squared plus bx plus c, and that equals 0. And we find the roots of this trinomial by saying, well, okay, here's our graph of that trinomial. So it's a parabola, whether it's a positive or negative doesn't matter. But we have these roots over here, we have roots over there, we have roots over there. Now this thing can look in many different ways. We could have something that looks like that, where it touches there, or we can shift it slightly that way and it can touch there, or we can have something that looks a little bit like that. We've got negative and our roots are over there. So we can have many different types, but each one's got a different meaning. So if we look at this, these ones are real roots, provided it exists, and these ones are real roots, and you can see there's two of them. Here, real roots, only one of them. This one as well, one real root and two real roots. But how do we actually get there? So we look at the quadratic equation and we see x equals negative b plus minus square root b squared minus 4ac. So you should know this equation by now, divided by 2a. And that's where we get our roots from. And specifically, this guy is what defines our roots, because we have negative b plus minus something over 2a. This is a constant, that is a constant, and this is a constant. But this one we are adding and we are subtracting. So if we write this, we have two values for x. X is equal to negative b plus or minus. Now, just to make this easier to write, we're going to make this b squared minus 4ac equal to some delta value, plus minus the square root of delta, divide that by 2a, or x is equal to, sorry, not plus minus, let's just say plus delta, or x is equal to negative b minus square root of delta divided by 2a. Now, what makes this great is we're simply looking at this delta and we're saying, well, if that delta is 0, do you agree that we're going to have negative b over 2a for the one x and negative b over 2a for the other x, because we have plus minus 0. So in order to get real roots, so we have condition 1. So I'm just going to start here. The first condition for real equal roots, for example, something like this one, where we have only one root. Real equal roots, we're going to have the condition that says delta. Remember, delta is b squared minus 4ac. So that's quite important. B squared minus 4ac. And delta is equal to 0. We have real roots. Real equal roots. But what happens if we don't actually care if the roots are equal? We just care that they're real. Well, real roots, we need delta, that guy there, to be bigger than 0. Why do I say bigger than 0? Well, because what we actually have, if you remember, is the square root of delta. And you can't square root a negative number, so if we want the roots to be real, we have to have a positive delta. Obviously, we can include that equal to sign in here, but then we end up with equal roots, which kind of defeats the point. And then the other one is we can have non-real roots. And non-real roots, obviously delta is less than 0. You square root a negative number, it becomes non-real. Now in these real roots, we can branch off a little bit, and we can say, well, there are two different types of real roots. There are real rational roots, and there are real irrational roots. Now, we have real rational, right? And then that is when delta is a perfect square. And we have real irrational roots, and that is when delta is not a perfect square. Okay, so for example, if delta is 9, then square root of 9 is 3. Everybody's happy, we have these rational roots. If delta is 5, we have square root of 5. Square root of 5 is an irrational number, so we have irrational roots. Okay, these rational and irrational, not so important. They're very important ones is number 1, 2, and number 3. Okay, so if we go on to the actual question, the question here says, question 1.3, we have, for which values of k will the equation x squared plus x equal k? Well, what we have here is, like I said, a normal trinomial, x squared plus x minus k equals 0. Okay, and if you remember correctly, the question said, for which values of k will the roots be no real roots? So they're asking specifically for no real roots. So they want the value for k that will give no real roots. In other words, delta must be less than 0. Remember what delta is? Delta is b squared minus 4ac. Now what we have here, we have ax squared plus bx plus c. And in this case, our a is 1, our b is 1, and our c is negative 1. Okay, so we simply work out what delta is, and we literally plug it in. We say delta is equal to, now that's the condition, And delta in this case is equal to b squared, which is just 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative k. Sorry, previously I said c was negative 1. C is negative 1k. And we look at that and we say, well, delta then equals 1 minus 4 times 1 is just minus 4 times negative k is just plus 4k. But we're not actually supposed to be using the equal sign. We're supposed to say, well, delta must be less than 0. So what we can say is this whole thing must be less than 0. Right? So we can go, that must be less than 0. So delta is less than 0, which is the above condition, and delta is equal to 1 plus 4k, so 1 plus 4k must be less than 0. Therefore 4k must be less than negative 1, and k must be less than negative 1 over 4. Okay, and that is the answer. That way we will have non-real roots, which was the original no real roots question. Okay, and that's it for question number 1. We'll have a look at question number 2.